Jai Hind students. In the previous lecture, we studied about various satellite subsystems, that was AOCS, TTCM, power and antenna subsystem. Today we are going to concentrate on the heart of satellite, that is called communication subsystem, because all the revenue which is generated by a satellite organization or space segment organization is through this communication part. So it is a very important, plays a very important role in the satellite communication, and the main component of a satellite communication subsystem is transponder. As I told you in the starting of this satellite communication, whenever we are talking about the satellite communication, here this is the earth. We have two stations and in the orbit we have a satellite. This satellite is basically communicating between these two earth stations, because during the communication between these two earth stations, if the distance between them is more than 1500 kilometer, then what will happen? That communication will not possible without use of repeaters, and that will increase the overall cost. Also, reception and transmission is not quite easy. That's why satellite communication came into picture. In that particular part, a satellite or man-made object is placed in the outer orbit of the earth. That satellite will get the signal on uplink frequency from the earth station and retransmit that same information towards earth station on downlink frequency. When we are talking about this uplink and downlink frequency, one point is always mentioned, that uplink frequency is always higher than the downlink frequency in the case of satellite communication. Sometimes students confuse, so I want to mention one thing. In mobile communication, when we are talking about mobile communication, uplink frequency is less than downlink frequency, but for the satellite, uplink frequency is greater than downlink frequency. And the main reason behind uplink and downlink, this higher arrangement, first one is power. To penetrate the outer atmosphere of the earth or outer atmosphere of the earth, the signal require high power. And when we required high power, means high frequency signal is required. To generate a high frequency signal, we required much power, and that high power is not available on the satellite. Also, as far as atmosphere height will increase, attenuation or path losses will also increase sufficiently, because the signal is going from the outside, from earth to the outside of the earth in the space. That's why these two problems, because of these two problems, uplink frequency is always taken greater than the downlink frequency in the satellite communication. And the transponder is the main part, that is a combination of actually transmitter and receiver with a processor part or with the processing unit. So what is actually transponder is doing here in the communication subsystem, that it is getting the data from the earth station, processing it, and again resending the data on downlink frequency to the earth. So this is the common diagram of a transponder, and here you can see that a transponder have a satellite antenna which is receiving as well as transmitting the data. Same antenna can be used through the duplexer, so it can be used in the both ways. That duplexer will give, after receiving the data, duplexer will give the data to low noise amplifier. Here you have to mention, I want to mention you one point. what is this low noise amplifier and how they are different from the normal amplifiers. Basically, in the communication, you always required high value of SNR, means signal to noise ratio will be high, means noise will be less and signal power will be high. When we are talking about an amplifier, generally when a amplifier amplify any signal, it will also increase the noise associated with the signal also, amplify also. And also amplifier will add its own noise to the signal. That will degrade the SNR. So, specific kind of low noise amplifier are designed which can only increase the or amplify the signal without amplify the noise associated with the signal. Also, they have very less its own amplifier noise, and that will help a noiseless that will help to create a noiseless signal. Then that incoming signal after passing through the low noise amplifier LNA given to the carrier processor. In carrier processor, the necessary processing will be done. If there is any damage to the signal or any other problem is there, that will be recovered, and then that particular signal is applied to power amplifier, and that power amplifier as a combination of low power amplifier and high power amplifier, and as high power amplifier has low output impedance, that's why that signal is directed towards the duplexer, and again the same satellite will send from the downlink frequency. So you can identify here that transponder is just a, you can say that just as a mediator which is getting the data from the one earth station and then sending the same data to the another earth station. So when we are talking about the transponder working, there are three types of transponders. These are single conversion transponder, double conversion transponder, onboard processing transponder. These are also known as bent pipe transponder. Single conversion transponder or double conversion transponder are also known as bent pipe transponder. How this bent pipe name came into picture? Actually, transponder is working is just same as a water supply line pipe. It is just you are sending the water from here and getting from here. This is just a bent pipe. That's why it is called bent pipe single conversion transponder. So, single conversion, double conversion, and third one is onboard processing transponder. When we are talking about the nature of the signal, single conversion and double conversion are basically processing the analog only. But when we are talking about onboard processing transponder, they are processing digital data only. Now, how this picture came into that single then double? Actually, in the starting of the communication, satellite communication, initially 300 megahertz bands are used. For the 300 megahertz systems, only a single conversion transponder, because that is basically related to the C band, and that will increase towards 500 megahertz frequency band. It means that band from 0 to 500 megahertz soon become congested due to the multiple operators, and that single conversion transponder will become out of focus. So after 1980s, double conversion transponder came into the picture, which is capable to the handle 100 megahertz band. Also, this picture will came into because single conversion transponder, you are using 6/4 gigahertz band, means 6 gigahertz uplink frequency with 4 gigahertz downlink frequency. But in double conversion, you are using 1411 gigahertz. 1411 gigahertz uplink and downlink. So this is about the transponder. Now about the construction of single conversion bent pipe type transponder. Here you can see that antenna is same on the both side. Maybe there is a single antenna which is using on duplexing mode. Actually 6 gigahertz is the uplink frequency. On this uplink frequency, the data will be collected by the transponder. Then a low noise amplifier, as I told you earlier, it will amplify only the signal power, not amplifying the noise. Then a 6 gigahertz band pass filter to restrict the another entries. Then a 4 gigahertz, because you have to bring down this 6 gigahertz frequency to 4 gigahertz. So we need a down converter. What is basically a down converter? Down converter is just a mixer with a local oscillator of 20 to 25 megahertz, means around 2 gigahertz. So after subtracting 6 gigahertz minus 2 gigahertz, we get a 4 gigahertz signal at the output. Means that same signal which is coming from the earth station on 6 gigahertz, after processing from the single conversion band pipe transponder, its frequency will become 4 gigahertz. Then that is applied to a 4 gigahertz low power amplifier and then a high power amplifier. This arrangement is used because low power amplifier have high output impedance, but the high power amplifier have low output impedance, and for the broadcasting it is required. So we are using a combination. Basically the incoming small signal is amplified by this low power amplifier. That amplified signal is applied to high power amplifier, and then it will be ready for the broadcasting. So this is about the single conversion, and as I told you, it was only applicable for the 0 to 500 megahertz frequency band, and as soon as 1980 will come, this whole 0 to 500 megahertz band will be over congested. So this second double conversion transponder will came into picture. Now this double conversion transponder actually having uplink frequency of 14 gigahertz and downlink frequency of 11 gigahertz. Remaining all process are same, just as you are using a low noise amplifier at the receiving end. For the transmitting end, you are using a 11 gigahertz low power and high power amplifier structure. But in between, you can see that you have a 14 gigahertz incoming frequency. To make the complete arrangement for the 14 gigahertz is quite difficult for the system. So here we use a combination of up converter and down converter that will bring down the 14 gigahertz frequency to 1 gigahertz. Then that 1 gigahertz frequency is converted into 11 gigahertz. This will be done because at lower frequency the costing as well as complexity of the circuit will decrease. That's why the construction of this part is quite easy and economical, and that will make double conversion more feasible for the satellite communication for the 1000 megahertz band. So here we are using a local oscillator of 13 gigahertz. This is making the down converter through the 14 minus 13 1 gigahertz. Then a local oscillator of 10 gigahertz adding up converter 1 gigahertz with 10 gigahertz making it 11 gigahertz. So this is double conversion transponder. These both single conversion as well as double conversion transponder are used for analog signal processing. But digital signal transmission taken over all over the world. So for the digital transponder, we are using this onboard processing transponder. These onboard processing transponder are basically used for multiple beam antennas. That multiple beam antennas are actually creating multiple beam at a single time with a single input or multiple input. That's why we are using phased array antenna on these onboard processing transponders. That phased array antenna are used for supporting multiple beams. Then the remaining process is same as the other one. Incoming signal on the uplink frequency came here to the receiver, where required amplification as well as demodulation will be done. Hybrid demodulation techniques or modulation scheme will be used for the processing part. Then they use a forward error correction decoder, because digital data is always encrypted or always created in such a way so that you can easily detect and correct the error. So forward error correction techniques are used for the decoding as well as encoding. After that, there is a onboard processor. That onboard processor will process the incoming data and create the multiple beam as per the requirement. Then the signal is going towards the FEC coder. So the data will be coded. Then the modulation and the transmitter as per the high power amplifiers, combination of low power and high power amplifiers. So similarly, to govern and operate and command all these blocks simultaneously on the same time and making a synchronization between them, a onboard controller is placed. Actually, in digital processing, synchronization plays a very important role. And to maintain that synchronization, this onboard processor is very much required. So this is all about the communication subsystem. So you can easily identify here one point very clearly, that communication subsystem or transponder is the heart of the satellite. And all the satellite making its placement in the orbit is always about the communication part. And this communication part is the smallest unit of a satellite. All other subsystems are just supporting this communication subsystem part. That's why it is the most important part of a satellite subsystem. So after this, we came into end of the subsystem, and just I am giving you some you can say that summary, that in combination you can understand these two subsystems in group, AOCS and TTCM. AOCS basically locating the satellite in its orbit, means attitude, height of the satellite and orbital parameters as well as for orbital control. So AOCS generated the same information. TTCM is collecting the data from the AOCS and generating the command. That command is fed to the thrusters and jet, so that the thrusters will be on and maintain the satellite location in its orbit. So these are two main points. Then second part is power. For power, you are using solar panels and rechargeable batteries. Solar panels and rechargeable batteries. You are using only these things. Then third part, that is antenna and transponder. Combinedly, they will make a communication part. So this is all about the satellite subsystems, and these 5 are the main blocks of a satellite which combinedly make a satellite and make a proper satellite communication system. So in the next lecture, we will discuss about satellite link design. Till then, thank you.